All right. Today, we're diving into something pretty groundbreaking in the world of AI. We're talking about how to create a world-class, expert AI model, but without those eye-watering six-figure costs. This is all about getting those genius-level skills on a super tight budget. I mean, seriously, just let that sink in for a second. What if turning a general AI into a specialized genius, a math whiz or a pro web researcher, didn't cost tens of thousands of dollars? What if it cost less than 20 bucks? That's the wild promise we're going to unpack today. So here's the fundamental challenge, right? We have these incredibly powerful large language models, LLMs, that are amazing generalists. I mean, they can write poetry, summarize articles, you name it. But you throw a really specialized real-world task at them and, well, they often fall flat. That leap from a jack of all trades to a true master, it's a really tough one. So why do they stumble? Well, for one, these generalist AIs really struggle to use external tools, things like a simple calculator or an API. They completely miss the subtle context of domain-specific instructions. And at the end of the day, they just lack that deep, specialized knowledge that a real expert has. So what you get out of the box is, let's just say, pretty suboptimal performance. Now, the traditional way we've tried to solve this is through a process called fine-tuning, but I want you to think of it more like brain surgery. You are literally going inside the model and altering its core programming, its internal parameters, to force it to become an expert in one single thing. And just like real brain surgery, it is invasive, it's risky, and it is incredibly expensive. Let's really break down that price tag. First off, you need massive computational power, and that can easily cost you over $10,000. The model is also super data hungry, needing thousands upon thousands of perfect examples to learn from. But you know what the real kicker is? It's that the model gets worse at everything else. The AI becomes a math genius, but completely forgets how to be good at other tasks. So you end up needing a whole bunch of different, expensive, specialized models for each job. It's not practical at all. Okay, so if fine-tuning is brain surgery, what's the alternative? Well, researchers at Tencent U2 Lab have come up with a brilliant new method. Instead of changing the AI's brain, you just give it a coach's playbook, basically a set of experiences and strategies it can study before taking on a task. It's an external, adaptable, and honestly a much, much smarter way to do things. And this slide just lays it out perfectly. On the left, you've got brain surgery. It alters the model's core, it's permanent, it's high risk, and you get a very narrow specialist. But on the right, you have the playbook method. You're just changing the external context you give the model. It's non-invasive, it's low cost, and you get an expert that's still flexible and can just swap playbooks for different tasks. It's a game changer. So the official name for this is Training-Free Group Relative Policy Optimization, or GRPO for short. The key takeaway is this: it's a way to teach an AI by letting it learn from its own experience. It looks at its own successes and failures, pulls out the key lessons, and then just feeds those lessons back to the original, untouched model as some helpful advice for the next try. No surgery required. Let's look at the diagram from the actual research paper. See that top path? That's the old way. The update arrow goes right back into the policy model, changing its guts. But now, look at the bottom path, the new training-free method. The policy model stays exactly the same. It's frozen. Instead, the learning loop just updates an external library of experiences. This is a huge shift, from changing the student to just improving the study guide. So, how does this actually work? How does the AI turn its own mistakes into wisdom? Well, it's this really simple, elegant loop. It's this beautiful four-step process. First, the AI just tries to solve a problem a few different ways. That's called the rollout. Then, it uses its own brain power to summarize and compare what it just did. Step 3, this is where the magic happens. It pulls out the core lesson, what they call the semantic advantage, like a key strategic insight. And finally, that little nugget of wisdom gets added to the playbook. Boom. The AI is now smarter for the next round. This is a perfect example right from the paper. The AI is tackling a tricky geometry problem. On the left, you can see it makes a couple of different attempts. Those are the rollouts. One of them fails because it ignores real-world physical constraints. By comparing those two tries, it distills this crucial piece of wisdom on the right. When solving geometry problems, always validate that mathematical solutions satisfy geometric constraints. That golden rule goes straight into the playbook. Okay, this all sounds great in theory, but does it actually work? This is where the story gets really, really exciting. Let's look at the data, because the proof is, without a doubt, in the performance. Okay, get ready for this because it's wild. On the left, traditional training. We're talking over $10,000 and more than 17,000 data samples. Now look at the right, training-free GRPO, $18. 18! And only 100 training samples. This isn't just a small improvement. This is a complete rewrite of the economics of building expert AI. And for that tiny, tiny cost, you get a serious performance boost. On this really difficult AMY math benchmark, the baseline DeepSea AI scored about 68%. After just applying the GRPO method, its score jumped to over 73%. That's a 5.4 percentage point gain, which is a massive leap in performance on a test this tough. But to me, this is the most powerful slide of them all. This shows you the flexibility. Look at those fine-tuned models. Retool was trained on math. It's great at math, but absolutely tanks at web searching. MiroThinker, trained on web tasks, is the exact opposite. They're what we call brittle specialists. But look at training-free GRPO. Just by swapping its playbook, it achieves amazing, state-of-the-art performance in both areas. It's an expert that hasn't forgotten how to be a generalist. So, let's zoom out. What does a breakthrough like this actually mean for the future of AI? Well, the implications are just massive. This is about making true expertise accessible to everyone. Basically, specialized AI has just been democratized. Small companies, individual researchers, even you and me can now afford to create these expert agents. We get this incredible flexibility. Just swap a playbook for a new skill, and that speeds up innovation like crazy, because trying a new idea is no longer a $10,000 gamble. It's about working smarter, not harder, guiding our best models instead of constantly performing brain surgery on them. The researchers themselves really say it best. They've created a new, highly efficient pathway that makes all these advanced AI capabilities more accessible, and this is the key part, more practical for solving problems out in the real world. And that leaves us with one last big, thought-provoking question. Now that the walls to creating expert AI have been completely torn down, making it cheap, fast, and flexible, the question isn't how we build them anymore. The real question is, what incredible, once unsolvable problems are we going to solve next?